Hey, this video is going to go over lesson 7.3, which was from last week. Now, I want to give you about 10 minutes at the beginning of class here to work through the check your understanding questions. Okay, so just to let you know, you are going to need a calculator to do some of these questions because you will need to use some of the buttons on the calculator to look up maybe a sine, a cosine, or a tangent ratio to find a missing side of a triangle. All right, so go ahead and pause the video here and work for about 10 minutes. Here we can quickly pick somebody to read. Random, say roll a die. Okay, let's roll a four-sided die. Okay, number 3. So if you're at seat 3, you're going to be the reader. Go ahead and pause the video, and then after 10 minutes, you can unpause, and then I'll go over the solutions. All right, so let's take a look at question number 1. If the cosine ratio with respect to angle theta is 4/5, find 2 possible sets of measurements for the 3 sides. Okay, so we know that the cosine ratio is the adjacent side to the hypotenuse. Okay, so what I could do is I can just go ahead and place 4 on the adjacent side and 5 on the hypotenuse. Now that still leaves me one more side to figure out, which I can use the Pythagorean theorem now to figure out that third side. Okay, so let's, for the moment, call this A, call this B, and call this C, so that we can use the Pythagorean formula. Okay. All right, A squared plus B squared equals C squared. So 4 squared plus, don't know yet, B squared equals 5 squared. 16 plus B squared equals 25. All right, we'll subtract 16 from both sides. That'll give us 9. Take a little square root on both sides, so B is equal to 3. Okay. So we can go back in here and write 3. Okay. All right, now for our second triangle, we want it to also have a cosine ratio of 4/5. Okay. Obviously, I can't just do 4 and 5 again because that would be the exact same triangle. Okay, so we could maybe scale up, right? And let's just choose something easy like a scale factor of 2. All right, so then this would be 8, and then that would be 10. Okay, and then we would also then scale up the third side by the same scale factor of 2. That'll give us 6. Okay. So we just use a scale factor of 2 to get triangle number 2. Okay, so these triangles are not congruent, but they are similar. Right? They're going to have the same angle measures. They're going to have the same ratios of sides. They already have the same cosine ratio, we know. All right, let's move on to question number 2. Now we want to solve for x. You can see that x is a missing side in each triangle. Okay. Well, the nice thing is we know one angle and we know one other side. Okay, so we could look up a ratio. Okay. All right, so let's go ahead and put the angle symbol here where we have 31 degrees, which makes x the opposite side and 8 the adjacent side. Okay. All right, so I know that if I'm interested in opposite and adjacent, that'd be the tangent ratio. All right, so I'm going to look up the tangent ratio for a 31-degree triangle. All right, so you can do this on the yellow calculator. Just make sure that it is in degree mode before you start working. All right, so the tangent ratio for 31 degrees is 0.6008. Let's call it 0.6009. I'm going to round that up. Okay. All right, so I've got the tangent ratio. The one thing, though, is that the calculator is going to give it to me as a decimal, and I would much rather have a ratio as a fraction, right? I want a ratio of 2 numbers. So we can always make the second number in the ratio 1. Okay. Right. So think of this as like my opposite side and this is my adjacent side, right? Or I can write a ratio using the picture, right? Opposite x to adjacent 8, right? So x to 8, that's also a tangent ratio, right? And those two ratios are going to be equal. Okay. So now what we can do is we can do a little cross multiplication. Okay, so we're going to get 1 times x, which is x, and we're going to get 8 times 0.6009. Probably should just leave the calculator here. Okay, so 8 times 0.6009 is about 4.8. Right, there you go. All right, let's look at the next one. Okay, so we can see that there's an angle here by point F, which is 55 degrees. 6 is the side that's opposite of that angle. X is the hypotenuse of this triangle. Okay. All right, now which ratio compares the opposite sides of the hypotenuse? That's the sine ratio. Okay. All right, so I'm going to use a calculator to look up the sine ratio for a 55-degree triangle, and we only need to write out the first 4 digits. It's 0.8192. I rounded the fourth digit there. Okay. All right, let's write this ratio as a fraction or ratio of two numbers, and then let's also write out the ratio using the actual values and variables in the picture. Right? So opposite to hypotenuse, that'd be 6 to x. 6 to x. All right. Set our two ratios equal to each other, and then cross multiply. All right, so the product of 6 and 1 is 6. The product of the decimal and x is, well, it's just the decimal times x. All right, so we've got to do one extra thing here, is we've got to divide both sides by 0.8192. All right, it's going to cancel on the right-hand side, so x is approximately, let's see, 6 divided by 0.8192, so like 7.3. All right. Okay, let's move that. Well, actually, let's resize it, and then we'll move it up over here next to the problem. All right, our last question says solve the triangle, and that means we need to find all the missing sides and all the missing angles. So a triangle has 3 sides and 3 angles. Okay. All right, so we already know that this angle is 90 degrees. This one up here is 28 degrees. And remember that triangles always add up to the magic number of 180. All right, so we'll do 180 minus 90 minus 28, giving us the last angle of 62 degrees. Okay. All right, now let's find some of those missing sides. Okay. I'm going to change my pen color to red here. Okay. All right, so the original angle we knew was the 28-degree angle, which would make this side over here the opposite side. This would be the adjacent side, and this would be the hypotenuse. Okay. Let's go ahead and put an x over there on the opposite side. So I want to try to solve for that one. Okay. Which means I don't really care about the adjacent side. Okay. Only care about finding the opposite side, and I already know the hypotenuse. Okay. All right, so which ratio compares the opposite to hypotenuse? That would be the sine ratio. All right, so we'll look up the sine ratio for a 28-degree right triangle. It's 0.4695. Okay. All right, let's turn that decimal into a ratio. Let's make the second number in the ratio 1. Okay, and then let's write the ratio based on the sides in the picture. So the opposite side is x, The hypotenuse is 13. So x to 13 is the other ratio, and we're going to set those equal to each other. All right, now we're going to go ahead and cross multiply. So one product is x, the other product is 13 times 0.4695, or 6.1. All right, so we can go back here into our picture, and we can write in this side as 6.1. All right, now we still have to go ahead and figure out the third side. That's the only measurement that we don't know, right? We know all three angles, boom, boom, boom. We know two of the sides, and just got to find the third side. All right, I'm going to switch colors here because now I'm going to be doing a different strategy, which is using the Pythagorean formula. A squared plus b squared equals c squared. All right, so I'm going to call that side A, we're going to call that side B, and the hypotenuse we're going to go ahead and call C. Okay. All right, so 6.1 squared plus b squared equals 13 squared. Okay, so let's see, 6.1 squared, oops, not 61 squared, 6.1 squared is 3721 plus b squared equals, I want to say 169. Let's just check. 13 squared is 169. All right, we'll subtract 37.21 from both sides. 169 minus 37.21. Okay, 131.79. Right, b squared equals 131.79. And then now we'll take a square root. Okay, square root of the previous answer. So 11.47, let's just call it 11.5. All right, so we can go ahead and write that in here, 11.5. Okay. So that was a lot of work involved. And in fact, we used almost every property we knew about triangles. We used the fact that the three angles have to add up to 180, right? That's how we found the third angle. We used some trig ratios. That's how we found so we already knew the first side. That's how we found the second side, using a ratio. And then finally we used the Pythagorean formula to find the third side.